Uh, Hello everyone. Today I'm going to talk about set and Cartesian product of sets. Uh, so let's start and see what is a set. So a set is a collection of objects that satisfy certain properties. For example, suppose let's take the example of this collection: Sachin Tendulkar, MS Dhoni, Virat Kohli. So whenever you see these names, then you can see that you in your mind is coming there Indian cricket players, very famous Indian cricket players. So so the property here on the collection is satisfying is that they are cricket players. Similarly, if you take the case of like mosque, church, temples, then you will see that the property of this collection is that they are religious places or worshipping places. Similarly, if you take the set 5, 10, 45, 1 lakh, 5,465, then the property this collection satisfies that all these numbers are divisible by 5, right? So you could say that. So whenever you are talking about a set, then you should remember that the set should have a certain should have a very definite, well-defined property. So that is the most important. So now the next is that a set is always written in capital letters. Then on the members of those sets, like for example in the first set, Sachin Tendulkar, MS Dhoni, Virat Kohli, all these are uh, members of this set, and they are known as in mathematics as elements of this set. Okay, so people use interchangeably, that is so a member of this set or element of this set. And a set in this, whenever you call that a set is written in this format, then it is written like this. You should remember this symbol, that is x belongs to A. So that is they say that x is an element of A. A set without any element is known as an empty or null set, and it is denoted by, I mean, symbolically as phi. So what is the meaning of this? So let me give you a very simple example. So if I ask you, give me a set that satisfies certain property, and the property is that a man having a height of 2000 centimeter. So can you give one element, name a person who is having a height of length 2000 centimeter? No, you cannot give. So that means this set does not have any element. So we call that a this is an empty set or a null set. Another example could be like, can you give some? Can you give some? Can you give some? Give a name of a fruit, okay, which is not grown in a plant. So it is very difficult. So fruit means going to be grown in the plant. Then any fruit which is not growing in the plant, which we can't give an example, right? So therefore, this is an empty set. So a set can be written in two format. One is called roster format or enumerated form. Another is called set builder form. So what is roster? Roster form? So I have given one example here, that if it is in roster form, you can write 1, 2, 3. So you are writing it, listing it 1, 2, 3, 4, dot 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 dot. But if you write it in a set builder form, then you directly write x such that x is a natural number. So you could see, so whenever someone is telling you write it in a roster form, so that means that person is expecting you that you write it in a listed form. And when a some person is telling you that, or a question asks you to write it in set builder form, then the objective is to write it in a very specific statement wise. So here it will be x, and x is the natural number, so it has to be the property. Correct. So this is the roster form and this is set builder form. Now we'll discuss what do you mean by a subset. Okay, subset of a set. And I will tell you that in a very simple English, subset of a set means whether the set is a part of this another set. Okay. So as per the definition, let's take A and B be two sets. Then the A is a subset of B that is A is a subset but B, that is a symbolically you write, okay? If for all x belongs to B, that means A is a part of B if every element of A is a part of B. By notation, A is a set of B if for all x belongs to A, it is a part of B. That is x also an element of B. So now let's see it in a Venn diagram. So you see in the Venn diagram, so the bigger set is the B set and the smaller set is the A set. You could see that A is completely inside B. So in this set, we can say that A is a subset or equally B. But you see the right hand side picture. In the right hand side picture, A is not a subset of B because there is an element you could see. It is a part of A, but it's not a part of B. That means A is not completely inside the B. So therefore, A is not a subset of B. So clearly notice that if someone is asking you to prove that A is a subset of B, then you have to prove like that. You have to randomly choose an element from A and prove that it is in B. And if you want to disprove that A is not an element of B, A is not a subset of B, then you have to search for an element who is a part of A but not a part of B. I think all of you get it, that whenever you are thinking that you are proving A is a subset of B, then you are proving all elements of A. I mean, randomly choose an element of A is a part of B or is an element of B. But whenever you want to prove that it is not a subset of B, you are searching for an element who is in A but not in B. So now you see that if someone wants to prove that A is a B, that means he has to prove two ways. He has to prove A is a subset of B and B is a subset of A. That means A is a subset of B and B is a subset of A. When each are subset of each other, then they are equal. Okay. And another thing that is by convention, that empty set is a subset of every set. So if you want to prove it logically, then how you want to prove it? Then suppose empty set is not an element of every, not a subset of every set. That means there exists an element in phi set, in the empty set, which is not in every set. But this is wrong. Because why this is wrong? Because empty set is a set with no element. Then how can there exist one element? Okay. Therefore, empty set is a subset of every set. Next, I discuss about after the subset. Next, I discuss about union and intersection. Okay. So, what do you mean by union and intersection? So, union means you see that if X, A, and B are two sets, then union means X belongs to A or X belongs to B, right? After the okay, so X belongs to A or X belongs to B. Intersection means X belongs to A and X belongs to B. So note that in union, either E belongs to A or belongs to E, it is fine. But in intersection, it has to belongs to both. X belongs to A and X belongs to B. And difference A, difference B means in the set, if you take out or remove the elements of B, what is remaining is known as A difference B. Like let's take it in the Venn diagram. You see this is A, this is B. So all these elements, okay, all these elements, okay, are A union B. This area is A intersection B because this is the area where X belongs to A and X belongs to B. Now this area is out of A. If you remove out B, then this is the area remaining. So it is A difference B. And this is B, out of that if you are removing A, then this is B difference A. So all of you clear what is union, intersection and difference, okay? So union means all these elements. Intersection means only this element which belongs to both. And A difference B means out of from A, if you remove B, whatever remaining. Similarly, B difference A is from B, if you are removing A, what is the remaining? Now I'll talk about this, what is called Cartesian product, okay? So Cartesian product actually it is always defined for two non-empty sets, and it is always defined for more than one set. So like for example, if A and B are two non-empty sets, then A Cartesian product B is defined as like AB, and where A belongs to A and B belongs to B. So A and B are elements of, and they are written like in the this bracket, this round bracket. So now let's take a very simple a simple example. Suppose A is 1 2 3, B is AB. Then A times B is 1A 1B, because you have to write like 1A 1B, 2A 2B, 3A 3C. So you have to write all these order pairs. Okay. And similarly, if you write BA, it is A1. So now you see here the order it matters. When you're setting A to B, then you're going A to B. When you're setting B to A, Cartesian product of A, then you're starting from B to A. So B A1, A2, A3, B1, B2, B3. Note that this is the most important thing here. Note that A product B is not equal to B product A. Like 1A is not equal to A1. So here order matters. Who is first, who is second. So therefore, all these elements of a two Cartesian product are known as order pairs. Okay, order pairs. And two elements of A cross B and B cross A will be they are always not same as long as A and B are equal. So therefore, I write A and B are equal is not equal to B, comma A. Two order pairs are equal if A equal to B. Got it? So this is the most important thing. Now I'll show you how to represent this Cartesian product in a graph. Okay, so you know that in the Cartesian product, so there is two sets. So I'll call this one set, and in this axis two set, and this is known as a Cartesian plane. Always remember that this is known as Cartesian plane. Okay. Now let's take a simple, take a simple example. Suppose A is equal to 2 1 and B is equal to 1 4. So A times B is equal to 2 1 2 4, 3 1 and 3 4. Now you see, so A is 2 3, B is 1 and 4. So A times B is these sets. Can you see? This is in the Cartesian plane. So 2 1, this is 2 1. 2 4, this is 2 4. 3 1, this is 3 1. 3 4, this is 3 4. So you see that once you have two sets, how you are representing it in a Cartesian plane. Okay. So today I just want to discuss only this much. So first we discuss what is a set, what is a subset, what are union of the set, intersection of the sets, and difference of the sets. Then we talked about Cartesian product, and in the Cartesian product, we discussed how order matters and why they are known as order pairs. Then how to represent all these order pairs in Cartesian product. Now, I think one question is that I represent here A times B. So now my question is, can you represent what is B times A? Okay. Now you tell me graphically whether are they same or not. Okay. So this is an exercise I'm leaving up to you, and you discuss and let me know in the comment box. Thank you so much for watching the video.